Dear students, in the last class, we came to know about continuous charge distribution. Before that, we have discussed dipole in uniform external field, electric field due to dipole, electric field due to system of charges, and in the beginning, Coulomb's law of electrostatic. Electric flux, if we remember, that it is defined as the number of field lines passing through a given area normally. An electric flux is a scalar quantity. If we take a sphere and here it encloses charge q, then and here a small area, element elementary area, then what will be the flux through this area? That we can say E dot ds. So let us today discuss the Gauss law of electrostatic, which is very important for our CBSE examination point of view. Generally, every year, 1 3 marks question from this section. First, the statement of Gauss law, which says the electric flux through a closed surface is 1 by epsilon naught times of the total charge enclosed by the surface. Here see, a spherical surface encloses the charge plus q at its center and its radius is r. If area element is ds, then what will be the electric flux through the hole? If we see its statement, it's simply the electric flux through a closed surface is 1 by epsilon naught times of the total charge enclosed by the surface. So here if we see, the surface encloses the charge q. So the total flux will be q by epsilon naught. Now we will discuss proof of Gauss law, though that is not directly in our syllabus, but we should know. First, the electric flux through the surface element ABC here is dE d phi is equal to E dot ds. What is E? It is 1 by 4 pi epsilon naught q by r square r cap. R cap is the unit vector in the direction of here the field, and area vector ds. Already we have discussed earlier the area vector. That area vector magnitude of that area and direction is perpendicular in outward direction. So if n cap is the unit vector along the normal of this area ds, then we can write vector ds equal to ds n cap, and that is equal to 1 by 4 pi epsilon naught q by r square ds, and again here we can rearrange r cap dot n cap. The value of r cap is 1, the value of n cap is 1, an angle between r cap and n cap is 0 degree. So its value, that is r dot n unit vector, is equal to 1. So electric flux equal to, here see, its value will be 1. So this electric flux is equal to 1 by 4 pi epsilon naught q by r square into ds, which is here. Thus the total flux, now it is the flux through a small area ds. So what will be the total electric flux through the spherical surface? We have to add up all such a small area, so that we will here cover the whole area of this sphere. So that will be electric flux is equal to surface integral E dot ds. And now this is equal to, here electric field already we got earlier, and if we integrate this ds, we will find it is the 4 pi r square. Now here 4 pi r square and this 4 pi r square cancelled each other. So what is left? It is q by epsilon naught, which is the statement of Gauss law. Now the advantages or some feature of Gauss law. So that might be a question why we are studying. So the great significance of Gauss law is that it is true in general and not only for the simple cases. Some of the important features are here. Gauss law is true for any closed surface, no matter what is its shape or size. Only the charges should be enclosed. If the system has some symmetry, then it is very much useful. For example, if we take a cube and if a charge is placed on its center, then all the faces from that center is symmetry. Then very easily we can find the flux through the each face, because the total flux, that is q by epsilon naught, now passing through the all 6 faces. So through one face it will be 1 by 6 times of q by epsilon naught. Here the equation, what's the equation? That is electric flux is equal to q by epsilon naught. Here this q in the equation electric flux equal to q by epsilon naught means the total charge enclosed by that surface. If a surface enclosing plus 2q and minus 2q charge, then the net charge enclosed by that surface will be plus q. Such surface which encloses the charge called the Gaussian surface. And another important features we can see, the Gauss law is based on the inverse square dependence on the distance contained in Coulomb's law. That is, the force between the charges is 1 by r square. So any violation of Gauss law will include departure from the inverse square law. Now, how we can, whether a question is here, whether we can get Coulomb's law from the Gauss law. So let us try. Once again, we have taken the same surface, a spherical surfaces, encloses the charge plus q at its center. Then we can find the electric field passing through this elementary area ds, and the electric flux, that will be surface integral E dot ds, that is q by epsilon naught. It is the Gauss law. So now just here we can write this term vector E dot surface integral ds is equal to q by epsilon naught. Now its value will be, it is the summation of this is such a small area, and its value will be 4 pi r square. So we can write vector E dot 4 pi r square equal to q by epsilon naught. Means now E equal to, if we transfer this 4 pi r square terms this side, we can say vector E equal to q by 4 pi r square epsilon naught, and its direction will be radially outward. Now question is, if a charge q naught is placed near the E, then the force on the q naught, because electric field is there, so whenever a charge is brought in a field, that will experience a force. And if we remember the definition of electric field, it is force per unit charge. So we can say the force is equal to the charge which is present there, that is q naught, into E, and its value will be q naught q by 4 pi r square epsilon naught. This q by 4 pi r square epsilon naught, it is the electric field present here. So here if a charge q naught will brought, it will experience a force, that is q naught q by 4 pi r square epsilon naught. It is Coulomb's law. Now some of the few questions just to recap. Let us see here a surface encloses charge plus 2q and minus 2q, and plus 2q charge is outside the surface. Then what is the flux through the surface S? Very simply, even we can, what is the total charge enclosed within that surface? That is plus 2q plus minus q, result will be q. So the flux will be, if we use the Gauss law, this plus q charge, total charge enclosed over this surface, while this plus 2q charge is outside surface, so there's no question of flux through this surface due to this charge. So that will be simply q by epsilon naught. Now a question leaving for you, calculate the electric flux of uniform electric field through the surface of a cylinder. Now the children, next we will discuss the application of Coulomb's law. Three applications in our syllabus: field due to infinitely long straight uniformly charged wire, electric field due to uniformly charged infinite plane sheet, and electric field due to uniformly charged thin spherical cell. And repeatedly every year, one question, one application of Gauss law from here. So thank you.